In this lesson, we will be learning about the distinction between relations and functions, and we will interpret various representations of relations and functions. Before we start, we want to make sure we understand what is the difference between a relation and what is a function. So starting with a relation is a pairing or correspondence between two variables that may be represented as ordered pairs, a table of values, a graph, or an equation. The arrow in the mapping diagram shows cities in set X. So if you look at set X, it has all the cities: Athens, Berlin, Cairo, and Ottawa. They each are paired with countries in set Y. So they're corresponding countries: Greece, Germany, Egypt, and Canada. The elements in set X are the domain, the relation, while the elements in set Y are the range of the relation. Key terms. Let's remind ourselves. What is a domain? Domain is the set of all X values, which are our independent variables of a relation. A range is the set of all the Y values, dependent variables of a relation. So the domain are all the possible values for X, and range are all the possible values for Y. So with that, let's look at example 1. State the domain and range for each relation. So reminding ourselves that in an ordered pair, X always comes first. So there's our X, there's our Y. If we're stating the domain in proper set notation, we would list all our possible X values. So stating our domain, and put big D representing domain. In set notation, we will list in increasing order all the possible values for X. So let's highlight them. We did that in yellow. The first value in an ordered pair is always your X value. Think alphabetically. The second would be your Y. So therefore, when we're stating our domain, we would list all our X values. 1, 2, 3, and 4. Close with a bracket. Your range, capital R, would be all the possible Y values. So -2, 1, 4, and 7. Okay, looking at example B. Example B, we have mapping diagram. So again, the set values for X. If we're stating the domain, it's all the possible values for X. So in this case, our domain is 1, 2, 5, and 7. Our solution set for range, all the possible values for Y. Now again, they're always stated in increasing order. So therefore, we'd start with -4, it's the lowest value, 2, 3, and 9. Let's close our bracket. Now, what makes a relation a function? A function is a special kind of relation in which each X value, so our independent variable, corresponds, and let me stress this, to exactly one Y value in dependent variable. So given this example, if you notice, a quick way of deciding whether a relation is a function, if it is expressed, the relation is expressed as ordered pairs, look at your X values. Okay, if they don't repeat, notice that the following relation is a function. We're going to use that property to decide on the following examples whether the relations are functions. But before that, let's state all the different formats for functions and relations. These include what we most commonly see is a set of ordered pairs. Again, the relation can be shown as an equation, table of values, a mapping, or often called arrow diagrams, or a graph. Looking at example 2, state whether the following relations are functions. So keep in mind each relation, if it is considered a function, each value of X has a distinct value for Y, meaning your X value does not repeat. So a quick way of checking is, again, I suggest highlighting, going through your ordered pairs and checking to see whether any x values repeat. Okay, so looking at that, I'm going to circle. Notice there's a -4 for x here and a -4, it repeats. So right away, we know this relation is not a function. We also see that, I'll just do it a different color to change it up, -3 and -3. So therefore, we can say, therefore, this relation is not a function. Okay, as we learned, a relation is a function. For each value of x, there's only one distinct value for y. I am moving over to b. Again, observe. Do we have any repeats for x? So I like to highlight them and then circle whether I see. So unique value for x, unique value for y. So therefore, we can say, therefore, this relation is a function. Okay, looking at our mapping diagram, we have a set of x values and we have a set of y values. Again, sometimes it's easier to rewrite the mapping diagram and show your relation as ordered pairs. And then we can quickly see whether, so let's put our set notation we have. So -2 and 6. -3, so set of -3 corresponds to 6 in the y set. And then we have -4 and 10, -5 and 11, and then -6 and 11. Okay, as we can see here, observing all our x values, none of them repeat. So therefore, we can say, therefore, this relation is a function. Continuing with D, we have, as you can see, another way of expressing a relation or a function is using a table of values. So again, by definition, a function means that for each value of x, there's only one value of y. So our quickest way to check is to see whether our x values repeat. As you can tell here, x repeats. So therefore, we can say, therefore, this relation is not a function. Okay, moving on. Another way we can tell whether a relation is a function given a graph. So if we're expressing our relation as a graph, then we can use a vertical line test. And the vertical line test is a test conducted to determine if a graph is a function or not. With this test, if any vertical line that is drawn intersects the graph, so that means it crosses the line of a relation at more than one point, the graph fails the vertical line test and is therefore not a function. So what we would do here, we take any vertical line, I'm using a ruler here, and we come across the graph. And if you notice, I'm just going to show because I am able to, that throughout the whole graph, my vertical line is being intersected more than once. Okay, you just take that vertical line and come across. So therefore, because it fails the vertical line test, we can say, A, this relation, which we know is a circle, is not a function. Okay. And why? Because it failed the vertical line test. Likewise, looking at B, again, you take your vertical line and you go across your graph. And if you notice, it would be touching, intersecting with my vertical line at more than one spot. So we can say, therefore, this relation is not a function. Okay, moving on to C again, you take your vertical line. Remember, this vertical line test only works if you're provided with a graph. So if your relation is being shown as a graph, therefore you can use that vertical line test. So as you can see here, throughout my whole graph, okay, it is only intersecting the vertical line once. Therefore, it passes the vertical line test, and we can say, therefore, this relation is a function. Okay, two more. Again, take your vertical line. Notice throughout the graph, it is only intersecting my vertical line at one spot. So therefore, we can say this relation is a function. I lost my ruler. There we go. Again, throughout the whole graph. Okay, so it passes the vertical line test, so we can say, therefore, this relation is a function. Okay, we have to explain that we know it's because it passes the vertical line test.